Welcome everyone. In this session, we will see about the measure of association used in case control studies, that is the odds ratio. The big question is in the case control study is the exposure more common among cases than controls? The answer to this question can be obtained by calculating the odds ratio. Why odds ratio, not relative risk? In order to calculate relative risk, we need to know the incidence of disease in exposed and unexposed group. But in a case control study, this information is not available because we start with cases and controls. So the risk and risk ratio can't come from a case control study. But we can obtain a very good estimate of relative risk from a case control study using odds ratio under specified conditions. Let us dwell into the concept of odds. What is odds? Odds is ratio of probability of occurrence of an event to probability of non-occurrence of this event. If probability of occurrence of an event is P, then odds is P divided by 1 minus P. Just to explain you in numbers, let us consider that in a year, India won 60 of the 100 matches played. What is the probability of India winning a match? Which is the number of matches played divided by number of matches won divided by total number of matches played, which is 60 divided by 100, and the probability will be 0.6 or 60%. Now, what are the odds that India will win the match? Here, recollect the formula that we used for odds, which is probability of occurrence of an event divided by probability of non-occurrence of that particular event. The probability of India winning a match is 60 by 100 divided by the probability of India not winning a match is 40 by 100. So, it is 60 by 40, or it can be 60 divided by 1 minus 60. Remember the odds formula, P divided by 1 minus P. When you calculate, it is 1.5. So, odds is the probability of occurrence of an event divided by probability of non-occurrence of an event. Whereas in probability, it is the number of successful events divided by total number of events. Let us consider these various scenarios where India has played 100 matches and won 90 of them. In a case, the probability of winning a match will be 0.9 and odds of winning a match will be 9. Let us consider India win only 50 matches. In this scenario, the probability will be 0.5 whereas odds will be 1. Let us say India won only 25 of the 100 matches played. In this context, the probability will be 0.25 and the odds will be 0.3. And let us consider the event as very rare, winning a match as very rare, as low as 5 of 100. The probability will be 0.05 and odds will be 0.05. You can see when the event occurrence is infrequent or rare, odds can be a very good estimate of risk and probability. So that's the reason we are using odds in a case control study. General formula for odds ratio. Odds ratio in a case control study can be calculated by odds ratio is equal to odds of exposure in diseased divided by odds of exposure in non-diseased. Let us first calculate odds of exposure in diseased, which will be probability of exposure in diseased divided by probability of no exposure in diseased, which will be A by A plus C divided by C by A plus C. A plus C and A plus C will cancel out and we will have A by C. That is, odds of exposure in diseased will be A divided by C. Similarly, odds of exposure in non-diseased will be probability of exposure in non-diseased divided by probability of no exposure in non-diseased, which will be B divided by B plus D, the whole thing divided by D divided by B plus D. B plus D and B plus D will cancel out and what will we have is B by D. How to interpret odds ratio? If odds ratio is greater than 1, it means odds of exposure among cases are higher than controls. That is, the exposure is positively associated with the disease. If odds ratio is less than 1, odds of exposure among cases are lower than controls, which means exposure is negatively associated with the disease. If odds ratio is equal to 1, it means odds of exposure among cases and controls are the same and exposure is not associated with the disease. When can odds ratio be a very good estimate of relative risk? Many are not comfortable with relative risk and OR is not immediately intuitive. But OR can be a good estimate of RR when the below mentioned 3 conditions are mentioned. That is, when cases are representative of all the cases in the population, when controls are representatives of all the controls in the population. Very important is when the disease is a rare one. Let us try to prove that odds ratio is a very good estimate of relative risk. We will calculate relative risk for a very rare disease in a cohort study. If it is very rare, A plus C will be very small when we compare with B plus D. So let us calculate the relative risk here. Since A plus C is small, A also will be very small. So we can say A plus B will be more or less equal to B. Similarly, if C is small, C plus D will be more or less is equal to D. Now let us calculate relative risk. Relative risk is incidence of the disease among exposed divided by incidence of disease among non-exposed, which will be A divided by A plus B, the whole thing divided by C divided by C plus D. Now we can replace A plus B by B and C plus D by D, where we will get the formula for odds ratio, which is AD by PC. So when the disease is rare, odds ratio can be a very good estimate of relative risk. Even in this example, you can see 300 is very small when we compare with 20,000, that the disease is very rare. When we calculate relative risk and odds ratio, they both tend to be the same. Remember, in cohort, we can get both relative risk and odds ratio, but in case control study, we can get only odds ratio. Association does not systematically mean causation. We have to have some potential explanation for association. We have to rule out bias in terms of defining a case, or the manner in which we selected the controls, or the way in which the exposure was measured. We have to rule out chance, and also we have to be very mindful of the confounders in the study. Only when we rule out the first three, then we can talk about causation. There are some weaknesses for case control studies. One, case control studies cannot be used for studying rare exposures. Also, it cannot be used to estimate risk or disease frequency in a population, since in a case control study, we start with cases. As mentioned earlier, case control studies are susceptible to bias, especially when we are defining a case, selecting a control, and the way we measure the exposure. How to fight bias in a case control study? We have to sample cases and controls. That is, we have to select cases and controls in the same way so that biases can cancel out. Also, bias can creep in when we are selecting the control groups, especially the hospital-based control groups. To fight this, we can think of selecting multiple control groups. Also, we have to prefer incident cases versus prevalent cases, and while selecting controls, we have to have a population-based approach instead of an hospital-based approach. Finally, the take-home message is, case control studies are analytical in nature, so they are used to test hypotheses. Case control studies occur within a theoretical cohort. Case control studies begin with the diseased and compares them to the non-diseased, whereas cohort studies begin with exposed and compare them to unexposed. Case definition, control recruitment are the key in designing a case control study and implementing it. And information on exposure is collected retrospectively in a case control study. Thank you.